likelihood of that problem. It doesn't necessarily require a hack. Now, during the whole checkout process, of course, it's quite likely that somebody's going to make a mistake and put an invalid address in, or invalid payment information, invalid shipping information. So the exception here is, pop up an error message and say, no, that's not a valid credit card number, no, that's not a valid zip code, or no, that's whatever, not valid. And then, the user corrects it and continues on. So that's pretty straightforward and probably a fairly typical exception, one more likely to happen perhaps than the first. And then the last here is another one that would also be fairly typical, which is the abandonment of the transaction either before or during checkout. People put stuff in shopping carts and then they don't check out. It happens all the time. Or in some cases, they're in the middle of the checkout. They just decide, I don't want this, or this is too much of a hassle, and so forth. Like, I think some websites that require certain kinds of information that people might not want to give during the checkout process. They probably have a pretty high rate of abandon during checkout. But that's going to happen. Some proportion of customers are going to abandon, and so we need to have some way of doing that. And in this case, it says the system logs the customer out after 10 minutes of inactivity, so make sure that there's not a resource leaking kind of problem. Okay, so here we're going to look at the tests that would be created to cover that, use case. So let me get my highlighter up here. I want to point out some things. So pretty straightforward. First step, place one item in the cart. Now, click checkout. Okay, so what are we doing here? Well, we're checking out with a single item. That's the smallest number of items that you can have in your cart in order for it to be a valid order. So that's what we've got here, is some kind of boundary value analysis that's going on. You should all see that. Excuse me. So we click checkout. So we should see the checkout screen now at this point. And then we input a valid address in the U.S., a valid payment via American Express, and a valid shipping method. Now, I'll point this out. Here with American Express and here with U.S. address, we see two kinds of equivalence partitioning going on. We're partitioning the destination addresses into U.S. and then subsequently you'll see international. And we're partitioning the supported credit cards. We apparently support at least American Express, and in fact you can see down here later, to jump ahead, we support Visa, MasterCard, and Discover. So there's the equivalence partitioning of the supported credit cards, and as I said, we've got equivalence partitioning of the destinations, U.S. or domestic, or U.S. or international, excuse me. So we this is step 3. So coming back to where we were, we put that information in, and we verify that the order. We verify the order information. We make sure that everything is shown as it was entered. So on that last page to confirm the order, that everything that is popping up there looks the same way it did when we entered it. And then step 5, confirm the order. And then at that point, the order should be in the system. Now here, you're probably going to need to actually go in to a database somewhere and check that the order is indeed in the database working its way through. Probably not enough to just look at the screens. And I think that's a good general rule too. When you're testing something, anytime a test is supposed to result in some sort of entry being made into a table or a file being generated or something like that, don't just take the system's word for it. So, oh, yeah, order confirmed. Well, sure, maybe, but check and make sure that that stuff is actually in there, data or file or what have you. Okay, so step number 6, we're going to repeat steps 1 through 5, but this time we're going to place 2 items in the cart. So that's more than 1, so we're going to try multiple items, but not too many. It's just 2. shipped to an international destination, as I mentioned, pay with a Visa card, so we're covering some more equivalence partitions there. And then step 7, repeat steps 1 through 5, but now we're going to do maximum number of items. We're going to fill the card. We're going to pay with a MasterCard. And then step 8, we're going to repeat steps 1 through 5, but we're going to pay with a Discover card. And that covers our equivalence partitions. So that's what we wanted to do. So at the beginning of this presentation, I had said, equivalence partitioning, boundary value analysis are mostly useful for testing inputs, and that's true by themselves, but they are also very useful in combination with other techniques like decision tables and state diagrams, as we saw in previous webinars, and use cases, as we're seeing here. Those allow us to test much more thoroughly. Okay, because you can imagine if we just tested the typical workflow, we only would have tested one credit card, and we wouldn't have tested minimum and maximum order sizes, and we wouldn't have tested U.S. and international addresses, and that would really not be sufficient to cover that use case, right? If you think about it. So, you have to, as I said at the outset, be a little bit more creative about what it means to achieve coverage. Okay, now here on this slide we see the exceptions. I shouldn't confuse those two things. So here we have the do not place any items in the cart. The cart is empty and try to check out, right? Now this is, of course, also a form of a boundary value on the order size, where this is the order size is 0. And we tested 1, 2, and maximum. We did not, as you look jumping ahead here, if you just scan ahead on this thing, you'll notice that we did not try putting too many items in the cart in this set of tests. We didn't try overflowing the cart, and that might be an omission. On the other hand, we're not worried about that. I mean, if maybe we don't think it's very high risk. The system might allow someone to exceed the maximum, because after all, it just means they're giving us more money. So maybe we don't care too much about that. But we do test the nothing in the cart. Okay, empty cart checkout. That covers that first exception. And then we have number 3. We're going to try to check out with the invalid address, invalid payment, invalid shipping, so various invalids. And we're going to make sure that the error messages pop up and they disallow us from proceeding to the next screen until those errors are successfully resolved. And that after those errors are resolved, we notice that we do go through to confirm the order. So we want to make sure that the fact that some errors occurred does not mean that the order can never be entered. That wouldn't be desirable at all. And then 6, 7, and 8, we're testing abandonment at various stages of the transaction. So we've got abandonment prior to entering the checkout process. We have abandonment in each step of the checkout process, address, payment, and shipping. And then finally, we have in number 8 there, abandonment at the last screen, the confirm order. We want to make sure that if the person doesn't click the confirm order button, that there is no order placed for them, because that would be kind of a problem if we tell somebody, well, the order is not placed until you click here, but we go ahead and place the order anyway. They might be a little bit unhappy about that outcome. So notice that again, we have equivalence partitioning happening here. We've identified 5 places where the abandonment can occur. Five things that are somehow a little bit different. 5 scenarios, situations that are somehow a little bit different, and called those equivalence classes, right? So there's abandonment while browsing. There's abandonment on the